Good morning and welcome to Promess's educational series, Selecting the Right Tools for Your Application. Today we're going to discuss Servo Press Basics. Just quick housekeeping notes. There'll be a sidebar on the right side of your screen where you can type in questions during the presentation, and then we'll be having a question and answer period at the end of the webinar. So thank you for attending this morning. My name is Stephanie Price. I'm a senior application engineer with Promess Incorporated. I've been here for 10 years and all of that is field experience. With me today is my colleague, John Lytle.
Good morning, Stephanie.
Good morning.
I've been with Promess for 20 years now. I am the application engineering director for Promess in North America. Let's start by talking a little bit about Promess. So Promess was founded as a Michigan corporation in 1984. Promess is a leading manufacturer in sensing and motion technologies. We're headquartered in Brighton, Michigan. We offer a complete line of electric servo-based press and torque solutions, with applications ranging from transportation, life sciences, consumer goods, and aerospace. Today's focus is going to explain what an electric servo press is and its benefits. We will take a deeper dive into some key components that make up the electric press itself and how these components are used to make up a quality system. So when you're selecting an electric press for your application, you can make an informed and intelligent decision. So let's get started by exploring a very basic question. What is an electric servo press? An electric servo press is a fully electromechanical press system. It typically consists of a servo motor, a servo amplifier, a motion controller, press mechanics, and some type of user interface. Some are very basic in nature that simply extend and retract, while other systems offer higher level functioning like multi-axis control, move to various sensors, higher level interfaces. Some even adapt to Industry 4.0, and so on. I personally have used electric servo presses in many applications, ranging from basic press fit like pressing bearings and seals in the transmission housings, to advanced assembly and test like steering gear function testing. In fact, right now I'm currently working on applications utilizing electric presses for ventilator assembly and mass production. Those are the hot topics right now as we try to battle against COVID-19. So as you can see, there's a whole myriad of applications that can and should use electric presses. But why?
That really is a good question. Why use an electric servo press? Well, first, they're cleaner and quieter than any other current technology out there. There's no hydraulic oil, messy pumps, or loud compressors like those associated with the hydraulic press system. Many have a smaller footprint as well, which is a requirement when space is really a premium. Second, and maybe the most important, is control. You really can't make cost-effective quality parts without having precise control in your process. The servo motor allows for controlled speed. So when you combine that with an integrated load cell, you can control the force down to fractions of a percent. Also, when looking at different systems, make sure the system you're looking at is 100% programmable. That allows changes to be made quickly and easily, and really just being able to change a single parameter makes it a lot simpler for you. And then closed loop feedback, that really gives you the ability to make real-time adjustments during the process, and that allows to compensation for variations within parts. And lastly, adding an external sensor incorporates critical dimension tolerancing, and it also gives you the ability to press to a function. Third, energy efficiency. A hydraulic press, for example, requires the pump to pump continuously in order to maintain the pressure so the press can move when needed. An electric servo press only uses energy when it's needed. So when the press is sitting idle, little or no energy is being used. There was a study that was done at the University of Kassel in Germany where they really took and delved into this. So the test conditions for the hydraulic, the pneumatic, and the electric, they used 1,000 Newton meters of force for each actuator, 150 millimeters of stroke, and then a cycle time of 1.7 seconds per cycle. And what they found was that the electric press really was more efficient, 90% energy conservation, as compared to the pneumatic and the hydraulic, which were 57 and 77% respectively. So let's now dive down into the components.
So most electric servo presses will consist of these components shown here. The press mechanic. The press mechanic is the moving portion that does the physical work. A force sensor gives the system force control. Also can be used to size the press load capacity. Some are integrated like shown here, and others can be external or maybe mounted to the end of the press ramp. Gearing. Some systems will use gearing. Sometimes gearboxes and pulleys are used, and it's used typically to help achieve desired forces and torques or for other reasons like size or things like that. Servo motor, servo amplifier, and the position feedback, these components apply power and motion to the press mechanic and gives positional feedback to be able to control the motion. All right, let's take a look at each one of these components and analyze their importance and how you can apply this to your application. Let's start with the press mechanic and sizing the press mechanic for your application. The heart of the press mechanic is the ball screw. The ball screw is the mechanical component inside the press housing that allows the ramp to be extended and retracted, like shown here with that yellow arrow. There are a few important aspects to note about the ball screw. One is the dynamic force rating of the screw and what the advertised force capacity of the press mechanic is and that relationship to each other. So what does that really mean and why is that important? Well, first we got to understand dynamic load capacity. Dynamic load capacity is the max amount of load a ball screw can handle while traveling through its stroke. Additionally, there's a rating on a ball screw called static load capacity. This is the max load the ball screw can handle while not moving. So what wears out a ball screw? Well, basically it's travel under load. So as that moves up and down while under load is going to put wear on that ball screw. So if you've chosen a ball screw for your press mechanic that is rated the same or lower as the advertised load capacity of the press, then you could reasonably expect a much lower life expectancy than one that was sized larger than the advertised load capacity of that press mechanic. Pretty basic. There is no industry standard or recommended formula for sizing a ball screw to its press mechanic. So it's important for the user to understand how the manufacturer sized that ball screw. So, and additionally, it's important to know about your application and what the requirements are also. So things like how much stroke is going to be used under load, the percentage of the rated force that'll be used, how many cycles, and so on. Then just simply investigate the technologies that are out there and do a comparison. As an example, Promess presses use at least a 2.5 times design factor in most of their press mechanics. So let's look at a hypothetical 40 kilonewton press with different ball screws to kind of get a better idea of what we're talking about here. So looking at the first column, we see nominal load or the force the press is rated at. So in this case, we have a hypothetical 40 kilonewton electric servo press, and then we're going to have different ball screw and bearing packages and see how this works out. Second is the average force. This represents how much force the press will see each cycle. The dynamic load capacity. Like I mentioned earlier, this is the max rated force the ball screw can handle while moving. The static load capacity, same thing, but not moving. And then we have some cycle dynamics here. Cycles per minute, hours per shift, shifts per day, days per week. And then based off all that information, we've come up with expected time until failure. So as you can see from that cycle data info, that's pretty conservative in my opinion. That's 2 shifts running 7 to 8 hours a day, 5 days a week. I know in a lot of applications I've been involved in, they're much higher production rates than that. So looking at the first column here, keeping in mind this is a 40 kilonewton electric servo press, we have a nominal load of 40 kilonewtons, an average load of 30, so less, we're not even taking it to its peak load, but we have a dynamic load capacity ball screw of 40,000 newtons. And based off that criteria, you can see here, you can expect that to fail within the first year of use, almost a half a year. So the next column represents same criteria, but now we've upsized the ball screw to a 60 kilonewton ball screw. The result, just over 2 years before expected time of failure. I know in a lot of the applications I work in, that wouldn't be acceptable. And I don't think that'd be acceptable for any end user that's using this product. Next, we double the size of the ball screw. So now we have an 80 kilonewton ball screw inside there. And it really only equates to 4.86 years before expected time of failure. Keeping in mind, these aren't even running this to its extreme. Then we come to the Promess ball screw package, which is 134,000 Newton ball screw that we use in our 40 kilonewton press. And that exponentially gets bigger and puts us out to 22 years, which is acceptable in most applications I work in. Here's a graph that kind of represents that exponential growth. So as you can see here, it matters how the press mechanic is designed relative to the demand you require out of it. So it's really important as a user of the product to be able to identify this and then get with the manufacturer you're thinking of using and find out that information if they're willing to give it out.
So next, the force transducer. Generally, most servo presses will utilize some type of force sensor, integrated or external. In most cases, the force sensor is going to be an indicator of the max load capacity, or the nominal load as in the chart before, that the press is capable of. So it's important that you size your press appropriately to your application's force requirements. It's also important to verify the safety factor depending on how the ball screw is sized. What you don't want to find out is that when you go to run off your machine, you've incorrectly sized this and now you can no longer run the machine off because it wasn't designed properly to begin with. So if you're using a Promess press, we recommend a 10% safety factor when sizing your press. Example, if your application requires 900 newtons of force, then a good choice would be 1,000 Newton Promess press, leaving a 10% safety factor. If you're unsure of what your application force is, then contact the Servo Press manufacturer. Many can help in determining the press sizes. For instance, at Promess, we offer free application testing on real presses to help you determine the force and the application requirements.
Okay, let's talk about gearing. Many electric servo presses will utilize some type of gearing. This can consist of a gearbox or some type of gear or pulley arrangement. In most cases, the gearbox and pulley arrangement are used to amplify the amount of torque a servo motor can output. This translates into higher forces a press mechanic can output when in use. In some cases, gearing is necessary, whether it's because of available components, certain component limitations, or you're trying to reduce the size of what you're working on, and many other reasons. However, be aware, oftentimes designers will incorporate high ratio gearboxes in their design simply to lower cost. Higher ratio gearboxes allow the designer to use lower amperage servo amplifiers and lower torque rated servo motors, which cost less, and in theory can achieve the same result. But be aware though, this is a money-saving tactic and often leads to much higher risk of failure sooner and more often, and can also lead to instability in the system. Higher ratio gearboxes make the press mechanic work harder, generate more heat, and have much more rotational movement, which ultimately can cause premature failure on key components. You can kind of see the example here. As a general rule of thumb, utilizing gear ratios less than 6:1 is going to result in much better performance and greater overall longevity on the press itself and its electrical components. The important point to note here is that a quality electric servo press will either utilize no gearbox or a low ratio gearbox.
So let's talk about the power to move. Really, this involves the servo motor and the amplifier. So as we discussed with the other aspects of the servo electric press, their basic understanding is needed here also in order to assure that you make the correct decision when choosing an electric press for your application. So with a servo motor, it's all about duty cycle and heat dissipation. Press motors and servo amplifiers generate heat, and if heat cannot dissipate quickly enough, this can cause issues like excessive wear and damage to vital components. So when you're looking at manufacturers, make sure that they're using adequately sized servo amplifiers and motor configurations. These packages should be sized and designed to run in continuous current range, not their peak. By doing this, it allows the servo motor to operate cooler by generating less heat. Less heat allows the motor to operate in its optimal state with no fear of premature failure, cycle interruptions, or faults. More importantly, this generates the press system can achieve its rated force and hold the force indefinitely. So let's look at this in more detail, right? Here we have a graph that shows the amperage, the press force, and time. This line right here indicates our peak drive amperage. When you have a properly sized motor, right, it's running within its continuous current and it can hold the force for an extended amount of time. When you're using an undersized motor, what happens is it gets up into that peak range, then it faults out, and now it's no longer holding its force.
That's a good point, Stephanie. That basically illustrates how cycle interruptions and things like that can become a real nuisance in production environments.
Yeah.
So what's right for me? Many times systems are designed with only cost in mind. And there are reasons why system A costs less than system B or system B is more money. But understanding how these internal components are sized, why certain components are chosen, and some basic mechanical aptitude will help you choose the correct press system for your application. So like understanding press force versus ball screw sizing, servo motor and gearbox ratings, and overall stroke length and forces required will help you make an informed and educated decision based off the criteria for your application. So a properly designed press will be able to achieve its rated load, maintain that load, operate within its optimal temperature range, and provide repeatable and accurate results for the duration of its time while in operation. Very important. This will not only lead to a successful project, but more importantly, your sanity when the application has finished its life cycle.
So let's move on to your questions. So I don't see that anyone has any questions, which is good. That means that we have thoroughly explained everything to you. Unless I'll give a couple more minutes. What size servo presses do we sell?
So Promess has a wide variety of servo press sizes that we sell, and all of our servo presses are sized like we just mentioned through this whole webinar here. But we have a whole bunch of them. I'm not going to go through every single one of them, but we range all the way down to a 0.2 kilonewton or smaller, all the way up to 1 meganewton sizes. And we have sizes all in between there. For example, we have a 100 kilonewton press system. We have an 80 kilonewton press system. We have 1 kilonewton, 5 kilonewton. We have lots and lots of different sizes. So for specifics about your application, call Promess and ask for either somebody in sales or one of the application engineers, and they can point you in the right direction for what size your particular application is needed. So those, what I mentioned, are basically our standard sizes. We also have variations of press sizes, presses that are more custom, different stroke lengths, smaller sizes, bigger sizes relative to their actual size and weights. We have a line of robot presses and things like that. So we have a lot of different size presses, but primarily, if you keep in mind, our presses are sized based off their max force rating. So when I say 100 kilonewton press, that means that press can do 100 kilonewtons. It can do it all day long.
Someone is asking the kinds of external sensors do we offer. Our controllers are able to take in a variety of different external sensors, from digital to analog probes, external force sensors, as well as pressure and temperature sensors. And the nice thing about that is that when we take those sensors into our controller, we're able to utilize them within the process so that your pressing can take those into consideration and press to a function or press to an external sensor, not just the press itself.
Yeah, so that's a good point. So like take a digital probe, for example. We have analog inputs like Stephanie mentioned where we can take in a digital signal or an analog signal. But take like a digital probe, we can take the digital probe into our digital input and then utilize that in our program basically very easily. So I can press to a input, or I could press to that digital probe. So I can use that to press to real precise tolerances if I need to, or press to a critical dimension and things like that. And then she also alluded to pressing to a function. We can take in other sensors too that aren't position or force, but more like pressure or temperature. And then we can correct or make corrections to an assembly based off that. And that's kind of like pressing to a function type thing. But it becomes part of the closed loop feedback so that we can react to that based off the input.
How accurate is the positioning of the press?
So a typical Promess press has an accuracy of positionally of plus or minus 25 microns. And there's a little note there to say that that accuracy is based off constant force and constant temperature. So going to the same force and maintaining the same temperature, we achieve that accuracy. If higher accuracies are required, that's where we would maybe suggest a digital probe, where now you can get accuracies down to the 1 micron level. So very, very precise. That's one of the key advantages of a servo press, is that their accuracies, like Stephanie mentioned earlier in the webinar.
What is the longest stroke available?
I
think it's 350.
No, I've seen strokes. We have some press designs that are out to almost over 1,000 millimeters of stroke. Our standard press sizes depends on the size of the press, and those range from 100 millimeters up to 660 millimeters. And then we have some custom units that have gone up over 1,000 millimeters for some applications we've done. So it's important to contact the application group or the sales group, and they can really point you in the right direction. So just because we have our standard line of presses on our website, for example, that doesn't mean there are other options out there or that we have. So feel free to call us and we can help you out.
So what are the variables that we used for the calculation of the life of the press?
So that's something we can email you specifically, because I don't want to get into that long calculation. There's a lot involved in that. So we have a calculation here that we use so we can take various inputs. So if you want, we'll have your information and I can give you that calculation via email. That calculation we generally do for all applications that we get involved with anyways, once we know the criteria for the particular application. Mine basically had some general information in there as far as the cycle time stuff. So I can play with those numbers, add, subtract, do whatever I need to do as far as your particular application to give you a more specific number to that. But I can tell you with most Promess presses, the ball screws are rated at a minimum of 2.5 times what we rate the press for. And that generally brings that number out to over 20 years. In some instances much more than that. But yeah, I can get you the calculation.
So someone's asking about the machine base on one of the slides and if we do integration. We do have workstations, but in terms of integration, we are not a machine builder and we do not do integration on a large scale. We work with our customers as needed.
Yeah, so Stephanie alluded to the workstation. So we offer a a kind of a turnkey solution in the sense that it's got a machine base, it's got a C-frame, obviously sized to our presses that we're using on it. It also comes with an electrical enclosure, the controls, and you can get a basic HMI with it if you want. That's used in different types of environments, but like prototyping in labs and things like that, or if an integrator isn't going to be used for a particular project and maybe that integration is part of the end user's scope of work or something like that, we will sell that type of thing. We also sell the C-frames only if a builder doesn't want to design and manufacture their own C-frame or base. We sell that kind of on an individual basis with our presses. But what we don't do is generally a rule here at Promess is we don't touch the part. And what that means is we don't design tooling, and we don't actually design the tooling that presses the part or fixture the part on our workstations or anything like that. That's left up to the experts. Those are the integrators and the builders that typically do that. So hopefully that kind of answers your question. We do offer turnkey workstations, but it won't be tooled up for your particular part, but it will be a functional system that you can utilize for prototyping or in production if that's something you need to do.
In regards to if we use gearboxes on our presses.
So some of our larger presses do utilize gearboxes. In the webinar, I mentioned that high ratio gearboxes we don't use. So our gearboxes are all generally, I think, 6-to-1 or less than that, and that's basically to achieve the mechanical requirements of the larger ball screws. All of our, like we mentioned earlier, all of our servo motor and drive packages are all designed to run in the continuous current range. So really none of them get up into that peak or anything like that.
Can we perform testing? We can. We don't just do assembly, but we are very much a part of testing during the assembly or after the assembly. I've been a part of steering gear, testing the steering gear. We also have our product development center. So I'm not exactly sure what testing, but we do have customers come in here, bring their parts. We work with them to develop their process here and verify that the forces they think they need for their system is what they actually need and that their press is sized appropriately.
Yeah, so the product development center here is headquartered right here in Brighton, Michigan. So you can either come and, obviously we can in these times we're seeing now, but typically you can make a trip here with your parts. We just ask that you bring some tooling or fixturing. We have a little bit here we can utilize. We can get pretty creative with what we have here, but our product development center is headquartered in Brighton, Michigan, and it's more than welcome for anybody to come in and do prototyping, testing, things like that. Understand more about their process or your parts and how they get put together, and we'll give you a full report on how all that goes together and works, and the data for it, the graphs for force over position, for example, the data related to that. Or if you can't make it out, we have the ability to press those ourselves if you give us some information about it, and we can email you back the data. We can take videos and things like that. So there's a lot of options, and we offer that free to our customers. So there really is no cost to that. So it's a great tool to take advantage of. As far as doing testing applications, I've been involved in a lot of testing applications actually with Promess. Stephanie mentioned the steering gear testing. We do all kinds of different types of testing with our press systems. We also have a full line of torque systems also, and with our multi-axis controllers, we can incorporate both to do various types of testing. Hinge testing for door assemblies, all kinds of different types of testing we do. So yes, the presses are designed for not only just press fit and things like that, but also for testing as well. So.
All right. Billy's asking if we have any servo presses that do not use the ball screw.
Currently we do. We have I might be able to answer 2 questions in one answer here. I also see a question, what is a robot press? So some of our more specialized press, I called it a robot press. We actually have a technical name for it. It's an integrated hard stop press or something like that. Basically, some of those presses where we need to lower weight, but still maintain the force, so it becomes physically a smaller press mechanic, those will utilize roller screws instead of ball screws. And that's kind of the advantage of the roller screw. Generally, you can generate more force in a smaller package. So some of our integrated robot presses utilize roller screws. And I think also some of our compact presses also utilize a roller screw. So it really becomes a size thing, why you would vary off of a roller screw versus a ball screw. As far as accuracies and things like that, they're pretty much unilaterally the same. And it really just depends on other components inside there to determine whether or not the accuracies are going to be similar to what I already had said. Our systems are all kind of designed the same, even when they use a roller screw. So our accuracies, no matter what the internal mechanic is, are always going to be what I mentioned earlier.
Right. How long can you hold a force?
So as long as we're running in the continuous current range, we can hold force forever. So until the electricity runs out from the power company that's supplying it to us. Basically, it can hold force forever because the electrical components are designed to do that. So to answer your question, forever.
Someone is asking in regards to the safety factor, if their force requirement is 50 newtons.
If their force requirement is 50 newtons, so the safety factor, I would recommend on lighter loads, when you start to get under 1,000 newtons of load, it really depends on your accuracies that you need in order for your application to be successful. So when we get to lighter loads, what I would recommend is possibly either a 1 kilonewton press or a 0.2 kilonewton press, and those have plenty of safety factor in them. And then if you need it to be very, very accurate, then what we typically will do is we'll supply an overload protected external load cell to the end of the press ram, and that'll give you accuracy at that 50 newton range, but we overload protect those load cells so that they can still withstand the full force of the press. So that's probably your most accurate solution for those lighter loads.
Is there preventative maintenance that is needed? Yes, it's recommended that you grease the press every million cycles.
It's every 250,000 cycles.
250,000 cycles.
4 times a year, whatever comes first, really. That's all the maintenance required with the ball screw press, at least for ours. There is no other maintenance required on it. We recommend that. We used to recommend 1 million cycles, but we figured, and you'd probably be okay with that, but people weren't greasing them at all. So we get presses back that have been running for 10, 15 years and never been greased, and they were pretty much deteriorated. We had to rebuild them a little bit. So we recommend 4 times a year, 250,000 cycles. That's it.
Can an electric press apply force anywhere in its stroke or only within a certain range? Anywhere within a stroke.
Yeah, so anywhere within its rated range. So a little more to that is in certain controllers, or I'll use Promess, obviously, work for Promess. I'll use our controller as an example. It's really the controller that is going to dictate how easy it is to control force or control position, for that matter, within its stroke. But they are completely 100% programmable. So I can move in micron increments if I wanted, all the way through its stroke. I could program it to do that. Or I could move that, I could do the same thing with force. I could incrementally increase the force through the whole stroke. Or I could, as forces change, I could move the position, extend and retract based off changes in the process and things like that. So yes, you can, throughout the entire stroke, you can program what you want it to do, from 0 pounds up to whatever it's rated for, from 0 millimeters out to whatever the rated max stroke of it is.
My application requires 200,000 pounds. Is this possible with an electric press?
200,000 pounds. Yes, that is possible. We have some solutions. Now, once you start getting into those higher force ranges, and what is that in kilonewtons, Stephanie?
That's what I was doing the math on.
So 200,000 pounds is roughly a meganewton, isn't it?
Yes, it should be a meganewton.
So yes, we do. We actually offer a meganewton press. So that would be 224,000 pounds. So yes, we have a press that can do that. When you get into high forces like that, it becomes, it's good to ask those questions because they're not very common out in the workplace at this point. But we have other ways we can also achieve those forces. We in our multi-axis controllers, we have some different techniques that we use or methods where we can take two presses and sum them together and basically link them software-wise to be able to move together and then achieve double the amount of force. So there's a couple different ways to do that, but as far as 200,000 pounds is concerned, yeah, we have a 1 meganewton press. We have a 500 kilonewton press also, and then from there we go down to a 300. These are standard press sizes. And then from 300 down, we get into the 200 range, 100, and all the way down with the smaller size presses.
Definitely, as technology keeps improving, the press sizes for the electric press keep increasing.
Right. And the demand keeps increasing. People want more and more control. And like we've been talking about through this whole presentation, is that control is really the main thing you gain with the electric servo presses.
What type of digital probe for higher displacement accuracy, an LVT or laser displacement sensor?
Actually, in my opinion, in my experience, more than my opinion, is a digital probe. So with the quadrature output, those have the highest accuracy, and they're a contact probe. And those basically get you micron accuracy and tenths of a micron resolution. So those are going to be your most accurate. Sometimes lasers can be equally as accurate, but there's always, using these systems in production environments aren't the best for lasers. When you're trying to measure off parts, surface finishes and other things affect that. So we have had luck with lasers, but the most accurate is going to be a quadrature output digital probe fed into our system. LVDTs and analog position transducers are good too, but they're an analog signal, so they're more susceptible to noise and things like that, but still offer greater accuracy. See, the real advantage of the digital probe is to be able to take that probe and mount it to your assembly or mount it to somewhere to measure off your part, so that you're measuring the part directly and then being able to press to that measurement. And that's what gives that accuracy more so. I mean, obviously you need an accurate probe to do that, but that takes all the mechanics and everything else out of the press system. And we have canned routines that allow us to do that. We have a canned routine called a measure step, to where we can press parts relative to each other and things like that and support critical dimensions on part prints. And that gives you the best accuracy of all. It takes deflection out of it. It takes the forces that vary within assemblies out of it, and you're measuring directly on that part. We have great techniques for that in our controllers.
Can Promess report back final position to monitor shallow or excessive press depths? So yes, we actually can, like you just heard John say, when you have a digital probe or even the press itself, the encoder on the press, our controller knows what's going on throughout the entire process, so we can report that information back. We have our own database that we are sending that information to, or we can send that information on to a PLC or another database that's needed. Ball screw versus roller screw. Can you provide the same force per size with a ball screw than a roller screw can achieve? The same force per size. So I think what Jeff is asking is, can you get more force from a ball screw versus a roller screw?
Yeah, typically, in my experience, I think they're equal. And I say that because some of our larger press designs initially had roller screws in them, and now they use ball screws. I think as ball screw technology has gotten better, I think they're pretty equal now. The roller screw to manufacture a roller screw generally takes a little more manufacturing, grinding and things like that, since it's a screw, it's more of a threaded screw versus balls rotating through an assembly. But at the technologies now, I think they both are pretty much equal. I might give the nudge to the ball screw because there's some big ball screws that have been developed just recently, which is why we're able to offer a meganewton press, and we've been very proactive in helping that design along, things like that. But to answer your question, I think they're pretty equal.
I'm not sure if Chris still has this question. He was asking in regards to if the dwell time affects the life of the electric press, and as long as you're running in your continuous current, it does not.
Yeah, there's two things to that. So like I've mentioned a couple times here now, is as long as you're within your continuous current rating of the drive and motor package, you're fine there. From the press mechanic side, if we look at the static load capacity, so if you're just maintaining force, if you noticed in that chart, those numbers were even higher than the dynamic load rating. So statically, if you're not moving that ball screw and you're just holding force, ball screws are great for that. They can hold lots more than what typically they're rated at. And I know other press manufacturers will use that static number as what they're utilizing for their internal mechanics when they talk to people about that. So just be aware of that. There's two differences. The static's always going to be higher than the dynamic because the dynamic is under load and through the full stroke of it.
And lastly, the optimal temperature range.
The optimal temperature range, that's a good question. I don't know that there's a definitive answer for that. For the electronics and the electrical components, there is, and that's basically on a data sheet, and that's per servo motor and per drive. For the press mechanics itself, we like to see that press mechanics stay cooler than whatever the drive and motor package is rated at. And we like to see it stay consistent, because a consistency allows for consistent thermal expansion, which results in positional accuracies and things like that. But I don't think there's a real optimum temperature. 40 degrees Celsius maybe or less would probably be optimal.
So Promess is releasing content regularly, so please be sure to check your email and our social media channels for news, updates, and invites to the latest Promess educational webinars. If you have any questions about the Servo Press technology that Promess offers, please email us at promessincorporated.com or visit our website at promessinc.com or call and speak with one of our application engineers. Thank you for your time today, and I hope that you got a lot of information out of it.
Yep, thanks. Talk to you next time.